Hi everybody, in this video you're going to be solving circular motion problems along with me. So please take a second to grab a piece of paper, a pencil, and a calculator, and let's get started. All right, before we begin, let's take a look at what our equations we have. So we have an equation for acceleration, which is velocity squared over r. We have an equation for the sum of the forces in the radial direction, and that's the mass times the velocity squared divided by the radius. We have an equation for velocity, which is 2 pi times the radius divided by t, which is the period. And we have the period equals 2 pi times the radius divided by the velocity. So we're going to be using these equations to solve this problem. Okay, let's look at number 1. The London Eye is the world's largest Ferris wheel at 135 meters high. It takes 30 minutes to complete one full rotation. If the bottom of the wheel is 10 meters from the ground, determine the radius. All right, it looks like this will be better to solve with a picture. Okay, so here is our Ferris wheel. And we said that the height, which is from the very top to the bottom, is 135 meters. But we also said that it is 10 meters off the ground, so this part is 10. So if we subtract off that 10 meters, we're going to get the diameter. So let's do that. 135 minus 10 gives us 125 meters, and this is our diameter. If you remember from math class, the radius is equal to the diameter divided by 2. So I'm going to do 125 divided by 2 to get my radius. And I get an answer of 62.5 meters. Okay, so we know our radius is 62.5 meters. Now let's take a look at B. Calculate the velocity of a car on the Ferris wheel. Okay, so we know, let's write down what we know first. We know the radius is 62.5 meters. We know the period is 30 minutes. Okay. And we're going to use that to find the velocity. So we look at our equation for velocity, and we get velocity is 2 pi r divided by t. Okay. So before we can plug this in, we need to change this 30 minutes to seconds. Go ahead and take a second to try and do this on your own right now. All right, let's do it together. I like to use dimensional analysis, so I'm going to say 30 minutes. And I know that there are 60 seconds in 1 minute. Minutes is going to cancel. And I do 30 times 60, and I get 1,800 seconds. Okay, so our period is equal to 1,800 seconds. And again, this is just so our units are consistent. We always need our period to be in seconds. So now let's plug this into our equation. So we have 2 times pi. For pi, I'm going to put 3.14. You can just put 3.14 instead of pressing the pi button on your calculator. That way you don't get a really long decimal. Our radius we know is 62.5 meters and divided by 1,800 seconds. So I'm going to do 2 times 3.14 times 62.5 and divide that by 1,800 to get my velocity, which is 0.22 meters per second. That's our answer for B. Okay, letter C is asking for the acceleration. Let's go back up to B because it asked for the magnitude and the direction. And what we just calculated was the magnitude. But let's say our car is here. If our car is here, what is the direction of the velocity going to be? Take a second to answer now. We know the velocity is always tangent. So in this case, it would be down. If it was over here, it would be up, to the side, okay? Assuming that it's going this direction, okay? Important to remember that the velocity is always tangent. All right, now let's look at C. Calculate the acceleration, magnitude, and direction of a car on the Ferris wheel. Okay, let's start with the direction. If our car is here, what is the direction of the acceleration? We know acceleration is always towards the middle, right? Always, always. Okay, so now let's look at that magnitude. So we're gonna need to look at an equation. Take a second to choose which equation are we going to use. Let's use this one. Acceleration is velocity squared over r. Okay, we know our velocity from the previous problem is 0.22 meters per second. We're going to square that and divide it by our radius, which is 62.5 meters. And so I'm going to do 0.22 squared divided by 62.5, and I get a 0.00077 meter per second squared acceleration. So this is really small, but that makes sense because if it takes 30 whole minutes to go in a circle, then it must be accelerating very slowly. Let's look at the last one here. If a car with its passengers has a mass of 550 kilograms, what is the force exerted by the car on the ride? All right, so we want to find force. The force the car exerts on the ride, the force the ride exerts on the car is going to be our radial or centripetal force. So we're going to use this equation. The sum of the forces in the radial direction is mass times velocity squared over r. Now, if you were in a more advanced class like AP Physics, you might have to figure out which type of force was the radial force, or you'd have to write a sum of the forces in the radial direction. But in our situation, we're only going to be dealing with situations where there's only one radial force. Looking at the sum of the forces in the radial direction, and that's what we're calculating for. So let's do that. We have the sum of the forces in the radial direction equals mass times velocity squared over r. Now we said our mass is 550 kilograms. Kilograms is the right unit. Our velocity we already calculated here is 0.22. Don't forget to square it. Divided by our radius, which we calculated here, is 62.5. Take a second to solve this. Okay, when I put this in my calculator, I do 550 times 0.22 squared divided by 62.5, and I get 0.43 newtons. Awesome. Okay, you can see in this that these problems build on each other. So you're going to need to find your radius first, and then find the velocity using the radius, and then we use the acceleration using the velocity, and the force using the velocity and the radius. So sometimes you need to find one property before you can find the others. That's something to keep in mind. Let's look at our second problem. This says the Gravitron has a diameter of 4 meters, and it rotates with a period of 1.7 seconds. So if you've ever been on a Gravitron, they're like these basically cylinders, and they spin around super fast, and then your body gets like stuck to it, to the side as it's spinning. Okay, so we have here that our diameter is 4 meters. And our period is 1.7 seconds. So A asks us to find the velocity of the Gravitron. So we're going to use our equation. Velocity is 2 pi r over t. Okay? We know what t is, but we don't know what r is. But we do know the diameter. If the diameter is 4 meters, what is the radius going to be? Well, our diameter is our radius divided by 2, or we can also say radius is diameter divided by 2, I should say. So we're going to do 4 divided by 2, and our radius is 2 meters. So now we can start plugging in. We have velocity is 2 times 3.14 times our radius is 2 divided by our period is 1.7 seconds. And when I plug that all in, I get 7.4 meters per second. Oops. And that is our velocity. Okay, so that's A. Now B, let's pick a new color. B is asking us to find the acceleration. So our acceleration, we know, is velocity squared over r. I want you to try this one on your own first. All right, let's do it together. So we have acceleration is velocity squared over r. Our velocity is 7.4. We're going to square that and then divide it by our radius, which is 2. So in my calculator, I'm putting 7.4 squared divided by 2, and I get 27.38 meters per second. I'm sorry, meters per second squared, because this is acceleration. And that would be my answer. Okay, let's look at the last one. Determine the magnitude and direction of the force the wall exerts on a 62 kilogram woman. Okay, well, we know the direction is always towards the center. Whenever we're talking about centripetal forces, forces exerted on an object that is moving in a circle, the sum of the forces, or the radial sum of the forces, is always towards the center. But let's think about the magnitude here. So we are given that, zoom back out, we have a radius of 2 meters, a period of 1.7 seconds, we have a velocity of 7.4 meters per second, an acceleration of 27.38 meters per second squared, and we know the mass is 62 kilograms. Okay, I want you to try this one on your own. Determine what is the sum of the forces in the radial direction. Find the equation, plug in your numbers, and solve. All right, so our sum of the forces in the radial direction is going to be mass times velocity squared over r. So if we plug that in, we're going to have a mass of 62 kilograms is the right unit, times velocity is 7.4, don't forget to square it, divided by the radius, which is 2. So let's do 62 times 7.4 squared divided by 2 in our calculator, and we're going to get 1,692 newtons. So if you've ever been in one of these gravitrons at like a fair or something, you'll notice that it feels like you're being pushed really hard. And that's because this is the force. It's kind of a high force that is exerted on your body. 1,692 newtons. All right, I have one more problem for us. Let's take a look at it. A giant swing has a diameter of 65 feet. I'm sorry, this is a typo. This should be 65 meters. Okay, so I apologize, this should be in meters. 65 meters and takes 30 seconds to complete one full rotation. Okay, so we have a giant swing. Oops. This is, maybe you've been on these at fairs where they sort of spin you around on these swings and it makes a circle. Okay, and we're saying our diameter is 65 meters. What is the radius? Well, we know our radius is our diameter divided by 2. So we're going to do 65 divided by 2 and get a radius of 32.5 meters. Okay. Now it's asking us, if the person has a mass of 40 kilograms, determine the magnitude of the force that allows the riders to move in a circle. So let's write down what we have here. We have, pick a different color. We have a radius of 32.5 meters. We have a period of 30 seconds. and we have a mass of 40 kilograms. And we're looking for the radial sum of the forces. Okay, so we know our radial sum of the forces is mass times velocity squared over r. And we have mass, we have radius, but what we don't have is velocity. So we're going to need to calculate velocity first by doing 2 pi r over t. Take a second to solve for velocity. Let's do it together. So we have 2 times 3.14 times our radius is 32.5 divided by our time or period of 30 seconds. When I put that all in my calculator, I get a velocity of 6.8 meters per second. So then I can plug this back in for my velocity here. Okay, and we have a sum of the forces. Now we're gonna plug right in, and we're gonna get our mass is 40, our velocity is 6.8 squared, don't forget to square your velocity, divided by your radius of 32.5. When I put this all in my calculator, I get a sum of the forces, which is 56.9 newtons. And that's going to be my final answer. Okay? So in this one, we were looking for the sum of the forces in the radial direction. So we came up with that equation as mv squared over r. And then we looked at what we were given, and we noticed we didn't have velocity, but we could calculate it using the numbers we were given. So first we needed to calculate velocity and then plug that answer back in to find the force. Thank you so much for watching this video. Please let me know if you have any questions. Have a great day.